This integrity lecture is from the Time Value of Money module. It's entitled Growing Cash Flows. So in this lecture we're going to deal with perpetuities and a growing annuity. This is really just a special application of time value of money, but it gives us a couple of formulas that can solve certain situations like growth in salary or tuition, things such as that, or if you ever receive a cash flow that lasts forever. So here we go. A perpetuity is a series of cash flows that has no ending. So in other words, you will get paid a cash flow forever, and it's always an equal cash flow. So if we tried to solve this, it would be the present value of a cash flow stream where we go from period 1 out to infinity. But to solve this, we need to relate the cash flows, otherwise it's unsolvable. So there's two ways we could do this. One, we could let the cash flows grow at a rate of G% every year. Or two, we could just let them be all equal. Let's look at the growth case. If we let each cash flow grow by G%, then for instance the cash flow at time 1 would just be the cash flow at year 0 times 1 plus G. The cash flow at time 2 would be the cash flow at year 1 times 1 plus G. So every cash flow is 1 plus G bigger than the previous cash flow. Now this is a geometric series, and it's kind of an advanced math class if we were to go ahead and substitute this out and solve, but let's skip that part. If we plug this in and do a little bit of reduction, we're left with the following. So the present value of a perpetuity is the cash flow at time 1 divided by R minus G. Now a couple of things here. If the growth rate is 0, so if every cash flow is the same over and over again, this formula just reduces to cash flow at year 1 divided by R. So it's just perpetuity formula. Second thing is R has to be greater than G. If the cash flows are growing faster than the cost of capital or the discount rate, we'd get a negative present value, and that's just not the case. That makes no economic sense. So here's the perpetuity formula. Simple example. Williams Inc. apologized to its stockholders for missing a dividend. They managed to promise to pay a dividend of $1 next year. The dividend will grow at 4% per year thereafter. If our discount rate is 10%, what would he pay for a share of Williams Inc. today? Well, it's a stock, so it's a perpetuity. There's no end point. Our growth rate is 4%. Our cost of capital or discount rate is 10%. And our dividend next year is 1. So let's apply to our formula. Real straightforward. We just take 1 divided by 10% minus 4%. Now notice here when we do this by hand, we put the percentages as decimals. So we get 1667 as a value for the stock. Second thing to notice here is these values are very sensitive to growth rates. So you're only as good as your estimate, in other words, when you do a perpetuity. Our second topic is a growing annuity. And if you think about things like tuition or Social Security payments, or sometimes your salary, it grows at a certain percentage each year. Often it's indexed to inflation, so it grows by the inflation rate every year. So our traditional annuity formula does not handle this. So we want to allow for a growing annuity. So it's like our growing perpetuity, except here we have an endpoint, or a final year payment. So here's how our formula adjusts. Notice where before we just had payment over R, now we have payment over R minus G. On the back half of our annuity formula, we have 1 plus G over 1 plus R. T is the length of the annuity. Let's look at an example. Hit pause and read through this before we proceed with a solution. Alright, so we're trying to value retirement. And it says we deposit 2% of our annual salary in an account that earns 8% a year. So 2% is not the growth rate, so let's be careful. Our salary last year was $50,000 and it will increase at 4% per year throughout our career. There's our growth rate. So G is going to be 4% for this problem. R is going to be 8%. The question is, how much money will we have for our retirement, which will begin in 40 years? So we're asking for a future value here. Unfortunately, we don't have a future value of a growing annuity formula in this section. We just have present value. So here's what we're going to do. We're going to get the present value of the retirement money, get it as one number or a lump sum, and then we'll grow it 40 years and find the future value. Here's our solution. Well, if we look at the current situation, you make $50,000, so 2% of that would be $1,000. That would be your contribution to your retirement. So for next year, we're going to grow that $1,000 by 4%. So my contribution next year, or cash flow at year 1, will be $1,040. Now we simply plug into the growing annuity formula. We have $1,040 as our payment. We take the difference between the 8% return on the account and the 4% growth rate in our salary. And we have 40 years to get there. But we're doing a present value. So the present value of our retirement is $20,254.12. We need to find the value at the end of year 40. So hit pause and take a look at this solution. Make sure you understand. So now our final step is, let's find the future value of a lump sum. Well, we just use the simple future value formula, present value times 1 plus r to the t. Our interest rate is 8%. We have 40 years. We grow it forward, get $440,011. So these are two special cases of time value money. It's a little advanced, and you'll see some of these problems on your homework. As always, feel free to email me with any questions or concerns that you have.